So just to give you some more condensed notes of all of this, some of the things I mentioned for our inputs, which we call the domain, that's all written here. And for the range, now that's everything. It doesn't just oscillate from 1 to -1 like it did with sine and cosine. Now it shoots up forever and down forever. Okay. We talked about the period is the big difference in each of these being pi, where it has issues and where it does actually give us x values for our y values of 0 are at the pi or the odd pi over 2's. And then remember, no amplitude technically, because there are no max or min values. So that's for your notes, just in case you wanted it. Otherwise, now let's get to a few more examples, and then you just go and practice and make sure that you got this down. So on this first one here, if you're feeling comfortable with these already, go ahead and pause it right here. Give these a try. If not, I'll continue on, show you how to do these and the little nuances that are a little different for either the period and the quarters, the amplitude, vertical stretch, or even a little bit of shifting, which we'll get to later. All right. So remember, the first thing I like to do is make sure I know what I'm dealing with so I can see that it is a tangent, and then put parentheses around the angle just in case. And because I know that something is indeed being done to the x of this graph, then I know that it's going to affect my x-axis, my period, in other words. And so normally, I would continue to draw my 4, pi over 2, pi, 3 pi over 2, and 2 pi quadrantal angles. But remember, our period for these are always pi. And if it's being multiplied, remember x's wanted the opposite of us, which is why they're x's, then we'll undo it by dividing. So our new period for this is going to be, instead of pi, very small, pi over 2. And then our quarters, we would take that pi over 2 and take 1/4 of that, which means our quarters would just be pi over 8. So when we go to draw this, I'm not going to draw this super small. Remember, I'm going to go a little bit to the right of 0 and a little bit to the left of 0, because that's what tangent's original one looked like. And remember, look up to get a tan. If it was cotangent, then I would have done this, but remember, it would not have been at 0. I would have shifted over, and this and that would have been my asymptotes. You'll get there. It's just going to take some time to keep working through that. If, until you do, you want to continue to write the unit circle and start evaluating those values, feel free to do that. Okay? So for me, I'm going to write my quarters down first, which was pi over 8, 2 pi over 8, 3 pi over 8, and 4 pi over 8. And I'm going to do that in both directions. Now remember, those are my quarters. Those are not going to be what I actually use for my asymptotes. My asymptotes will actually be half of that. Okay, so from 0, I'm going to go over the pi over 4 and negative pi over 4. And I'm just going to draw one period of this rather than doing more than that. Now, just to confirm that this is correct, remember, I'm looking at going pi over 4 to the right and pi over 4 to the left, which means the whole period of time that I'm going to graph this one period would be pi over 4 plus another pi over 4, so 2 pi over 4s, or pi over 2, which remember, that's what we said the period should be. Okay, so just to make sure, I know this is different, it's a little bit harder than the sine and cosine, but now that I have my field goal set up, I'm going to make sure that I nail it and kick it right down the middle on my x-axis. Then why do we have those other tick marks? Well, remember, those are quote-unquote amplitudes, okay, which would be my 1 and -1. Typically, those were our pi over 4s right here, but remember, things changed for this one. So because this is my normal quadrant 1, and then this would be the normal quadrant 4, and we know that all students take calculus. And since we're dealing with tangent, positive and negative. So this would be the positive one, and this would be the negative one. And remember, tangent should be looking something like this, because we know from left to right, we look up to the sun to get a tan. And that's it. If you wanted to do more, then you could, right? This would be our next negative one. This would be our 0, and then we'd have another here, and we'd have to do something like that. And then same thing over here. This would be our 1, our 0, and then we could do that. So if you wanted to kind of continue with what you have, no problem. It's totally up to you how much you do. It's just a matter of, do you understand it? Okay? So if you didn't try that one on your own, go ahead and stop. Try part B, but I must warn you, there is one other new little thing that I want to warn you about, and that's that negative. Obviously, you can all see the 3 and the 1/2, and hopefully you know what effects those will have, but that negative is an extra piece that I wanted to make sure that I highlighted, and hopefully you also know what that is going to do. Okay, so go ahead and give that one a try, and then I'm going to show you how to do this one, and also a nice way to check your answers, check and make sure you're doing these correctly via an app or the web. All right, if you gave that one a try, well done. If not, hopefully you will be able to after this one, but let's get to it. Let's talk about our period and how that's going to possibly change. We know that for tangent and cotangent, it's half a circle. So it's just pi initially, but that is going to change because of this that's being done to the x. So remember, we always undo whatever's being done to it. So since it's being multiplied by half, we're going to divide by half, which obviously that is then going to change what? Well, it's going to have the inverse effect because we're going to have to multiply by 2, that fancy 1 there again, to cancel that out and get a period of 2 pi, what we're actually used to. And therefore, if we cut that 2 pi into fourths, we know that that's going to give us quarters of pi over 2. So that's going to be 1 pi over 2, 2 pi over 2, 3 pi over 2, and 4 pi over 2 in either direction. And then from there, we've got that taken care of. What about this 3 and negative part? So remember, the 3 is not being done to the x, so therefore it's going to have the effect on the y. And since it's multiplying, remember, y's are y's. We do what they say. So the amplitude for this would just be 3. If I give you this problem and I only ask for this, remember, technically, there isn't an amplitude. So that's why I put these quotes around it. We're still going to use that to stretch this tangent, these y values, vertically by 3. But officially, there is not an amplitude if you are asked to answer it. Okay? And don't forget, amplitudes are always positive. So what are we going to have to do with that negative sign? Well, remember, that is what is called a reflection. And it is going to reflect all of our, since it's not being done to the x, it's going to affect our y values. It's going to take then, therefore, everything on both sides of our x-axis, which some are going to be positive and some are going to be negative, and we're going to flip-flop them. They're going to become the opposite of what they were. Okay, so we call that a reflection. And therefore, yes, we will have a reflection on this one. Okay, so what does this all look like? How are we going to put it all together? I always like to start with my asymptotes. Okay, you got to watch your asymptotes in order for you to get this correct. Okay, so be careful with that. I'll start with my asymptotes, which remember we said our quarters were pi over 2. And since we're starting at 0, there's no horizontal shifts. Remember, our asymptotes do not start at 0 because it doesn't have the 0. So we're going to start at pi and negative pi. And like I mentioned, if you want to do more than just one period, that's fine a lot of times with these, because That's not a whole lot to do. They will have multiple sets of periods in either direction. You'd have to go out a distance of 2 pi further to the right. So we'd have to go and make our 4/4 again to get all the way to the next one. So I'm just going to do one, and remember, since I have my field goal, I'm going to kick that field goal right down the middle and put my 0. And then remember, we normally would have our 1 and -1 as our quote-unquote amplitude, but that changed to 3. So I want to make 3 tick marks. And that 45 that we normally have, which is right in the middle, because our period changed, right, then it also changed there. But it's still always that 1 in the middle of our 0 and our asymptotes. So this would still technically be our quadrant 1. So normally this would be where it's positive 1, but remember it went to 3. But because of that negative, we said the negative is going to have the opposite effect. So the positive 1 is going to be stretched and reflected to 3 and in the negative side. Where the -3, which would normally be here, will be flipped to +3. There. So when I draw this, it's going to look a whole lot like what? Remember I mentioned to you all that you can hang your coat. So this is actually going to look like a cotangent. Sorry, it's pretty small here. Doesn't have as much curve as it normally would. But cotangent is what we hang. Tangent is usually where we look up to the sky. But remember, it's the reflection that makes it look that way. Right? Where all of our negative stuff flipped up to the positive side and all of our normally positive stuff flipped down to the negative. Right? So that's it for that one. Hopefully you're able to kind of follow along. Remember, I'm just doing one period. If you wanted to continue it on and do a few more, that's perfectly fine. Just make sure that you have in the middle there, and you still have, that's right pi, and that's left pi for our whole period of 2 pi. Right? So this whole thing right here would also have to be 2 pi. So that would take me all the way to 3 pi there, excuse me, not 4 pi. So before I get to any others, I wanted to quickly show you Desmos. It's a nice free software that you can look online or even download to your iOS or Android device. I have just here on my iPad the app that I'm utilizing, and I already typed in all the examples that we've both done and will do. So the first one here, I already typed in y = tangent x, so I'm just going to click on that, and you can see it should look a lot like mine, which was that. Okay, obviously mine looks a little bit better, of course. But no, that's because if you look at the x-axis, it's our regular old x-axis that we're used to with the 1, 2, 3, 4, or they're going by 2s. Okay, where mine actually has the exact zeros and pi/2 asymptotes, things like that. Right? But remember, if I wanted to tell you what this is about, I know pi is about 3, so this is about 3/2, or approximately 1 1/2. So that's where that would be about. So if I look at this and I'm looking at 1 1/2, you can see that that would be right around where a vertical asymptote would be. Which if I wanted to actually physically put that in, I could do another one and say that would be where x is equal to 3/2 everywhere. And you can see that's where that line would be, one of my asymptotes. What about cotangent? Well, remember, tangent was where we looked up from left to right to the sun, and cotangent actually had, starting at 0, a vertical asymptote, and then it went downwards. Okay, and now you can see that 1 1/2 is actually a 0 now. Because if you remember, beautiful mess, isn't it? That these two functions, tangent and cotangent, are complements of one another. Right? So you can play around with this app. You can change things around. If I wanted to change this along the x-axis, I can multiply the x by 2 like that third line there. And if I do that and graph it, you can see I will have the green one there twice as many because it's going to change my period. Okay? And it will get there in half the time. So all of these things you can mess around with. The one that we just did was also tangent, but it looked like that. And so you can see mine should resemble that, but my drawing isn't nearly as neat, but it is more precise because I have exactly where those asymptotes would be by the labeling that I did on the x-axis. Where theirs, it's harder to see. If you look at that first asymptote to the right there, it looks like it's between, I don't know, right around 3, where it would be. And if you look, my first asymptote is exactly right there at 3. So yeah, pretty good. Mess around with that. Feel free to go through and do as much or as little as you want with Desmos. There's also GeoGebra if you wanted to try that one out as well. Okay? Now, one thing we have yet to do is shifts, whether it be a phase or horizontal shift or a vertical shift. So let's start with this one, and then we'll do one more and call it good for this section. If you're feeling comfortable already and you want to go for it, do it. I'm going to start you with this one, and it is tangent. Now there's nothing being done to my angle, so I know my axes are not going to change. So I'm just going to do 2 in each direction to have my 4/4. So 0, pi over 4 and pi over 2, negative pi over 4 and negative pi over 2. Now normally that's pi over 2 and pi and 3 pi, but remember the period for these is pi rather than 2 pi. So my quarters is going to be pi over 4. I will draw my asymptotes through those, and I will put my 0 that normally is there. So that means I will start by taking my 0 in the middle, and then at that pi over 4 right here, I would have gone up 1. And then that pi over 4 to the left, I would have gone down 1. So I will then graph this. If you want to put the tick marks there and there, there's my up 1, and then there's my down 1, which means I'm going to go ahead and extend these a little bit, shift it down here, 2, draw it, done. That's the final graph of y equals -2 plus tangent x. And you may be wondering why they put it in the front of the trig function, because if they wrote it like this, a lot of people think it has to do with the x. And unless they put parentheses around it like that and include all of it together, it should not be. It would just be like that. So since they don't want to write extra parentheses, they will put it in front so that there's no confusion. All right? Again, I hope this is getting easier for you. If it is, here's our last example. Go ahead and give it a shot, and then I'll go over it with you. All right. If you're able to get that, well done. Head on over to your homework whenever you're feeling good, and then just make sure you practice it until you get it. Throw different examples. Go to Desmos. Mess with that a little bit so you can see when you change things around how that moves and changes your graph as well. So the first thing I want to talk about is the period of this, because it is cotangent. All right, I know that nothing's being multiplied to the x, so my period will stay the same, which means my quarters will stay the same, so I can start labeling my x-axis. Next, we'll talk about that quote-unquote amplitude, which again, since there's nothing being multiplied in front of the trig function cotangent, then it is a 1, that standard one that we talked about. So those are the first things that we spoke about when we started this graphing with sine and cosine. Still translates over, no pun intended, to tangent and cotangent. But what about the other translations that we need to talk about, the shifts? whether it's a vertical or a horizontal or phase, same thing, or even a reflection. Any of that stuff going on, well, the one good thing is there is no reflection. There's no negative, so that's good. But there is both a vertical and horizontal shift. So with that, you need to know what is affecting what. And of course, if it's not being done to the x, it's going to affect the y. And remember, y's are y's, so we will do what it says and shift up 3. And what are we going to shift up 3? Everything. And of course, the harder one is always dealing with your x's. You know what I mean? I don't. Pi over 2. If it's being added, remember we're going to do the opposite and we're going to shift negative or left pi over 2. So when we start this graph, I'm going to do it very lightly with, say, yellow here. And because it is cotangent, remember we would have started at 0 and then gone for that entire thing, that period of pi, all the way over here. And then we would have put the 0 in the middle, and then our 1 and -1, and then drawn it like this very lightly. So I'm trying to use yellow just to let you know that this would have been my original graph. And again, I could have done that over here, the 0 in the middle, the 1 and the -1, because there was no change in my amplitude. And that would have been the full drawing of just y equals cotangent x. But we have 2 different shifts that we need to put onto this. The easiest one I'm going to go ahead and do first, which is the vertical. So I'm going to do that first by shifting what up 3? Everything. So that means I'm going to take 1, 2, 3, 1, 2, 3, and technically my asymptotes as well, and I'm going to shift everything up 3. So I'm just going to grab my x-axis, and I'm going to go up 1, 2, 3, and I'm going to plot that. So now all of these things will be up. So I actually got to make 4 tick marks so that I go up 1, 2, 3. 1, 2, 3. Let me make my tick marks here. 1, 2, 3. And so then that would be what the new graph would look like, shifting up 3. And of course, the same thing here. By taking those and moving them up 3. Okay, but this is starting to become a mess. And don't forget, I still have another shift that I have to put on, and that is the what we call phase or horizontal shift. I have to shift everything left pi over 2. So if I'm going to go left pi over 2, that means I'm going to start with my asymptotes. Remember, start there so that you have those boundary lines, and then once you have that, kick that field goal right down the middle. So when I change all of these, it's now going to shift everything to the left pi over 2, which I'm going to clear some of this stuff so that we can see it a little bit better. And I'm going to start by making all of these left a few more values. So I'm going to start by going pi over 2 to the left, which means this is going to change to there. The 0 is going to change to there. And if you notice, unfortunately, that looks a whole lot like what? If you said tangent, very, very good. But don't forget, everything also got shifted up 3. So instead of putting our 0 here, and our 1 here, and our -1 there, remember that is for tangent. We were dealing with cotangent. We just had to put that left pi over 2 shift, and now we can do that up 3. So I'm going to take my x-axis, and I'm going to move it up 1, 2, 3. And I'm going to draw that there while also getting rid of those other shifts that I had done. And so now I can go ahead and put my 0 in the middle. And remember, for cotangent, we're dealing with that positive and negativeness, but since we moved it, it's still going to be the cotangent, the coat that we are going to hang in the downwards direction, decreasing from left to right. All right, so that one's a little tricky, and again, that's just one period. If you wanted to continue to shift it left, then it would look a whole lot like your tangent function, but going downwards because of cotangent, and of course shifted up 1, 2, 3 from the x-axis. All right, continue to work on these. The good news is tangent and cotangent, in my opinion, are the most difficult. Sine and cosine obviously are the easiest ones to graph, and so therefore should be their reciprocal functions, cosecant and secant, which we'll get to next time. All right, until then, keep practicing, keep working hard. I'll see you then.